Hi, and welcome back. For the sake of privacy and all that, I'm going to keep your name out of the video. This video is going to try to summarize everything that we did in class so that you have an opportunity to catch up. And I'm going to end up sharing it with the rest of the class anyways, in case they want to have a quick refresher. So there's a lot of lessons I think that we need to cover, but luckily some of them are just labs and you can wait for me to, you can wait until you come back and see me face to face and we'll get you filled in. The first lesson you might want to focus on that you may not be able to do on your own is this thing called the particle theory of matter and the classification of matter. So we sort of did that together. Here we go. So to start off the lesson, I asked everyone in class to cut out this set of, I guess, pictures, just one of these. So I cut little strips for every single student, and they were to cut this out, and they were to organize this based on what we call compounds, compounds, and a mixture. So that's the only guidance that they were given. And whether from their past knowledge or from their problem solving skills, they were able to figure out which six was under element, which six was under compound, and which six was under mixture. You can pause the video and actually try that yourself. I'm going to go ahead and write the, I guess, the answers straight off the bat. So let's start with red being elements. Elements is this one. Well, that doesn't really show. So how about I do it in a thicker pen? Elements, elements, and elements. Okay, out of the red check marks that I've given, see if you can identify what seems to be a common theme between these images. Okay, may not be as easy as you might think, but if you have some background on this or you've done something like this, you might get it. Here are compounds in dark blue. Here's a compound, 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 and compound. Those are my six. Everything else, and I can do that in green, are going to be mixtures, a mixture, a mixture, a mixture, a mixture, and a mixture. Okay. I think for mixtures, it's pretty self-explanatory. You can see that inside this picture, every single thing that I've colored green, the contents of each of these pictures, you see, I guess, these molecules or these uh, bundles of spheres that look different from each other. And that's essentially what it is. Okay. That's what a mixture is. We, at a molecular or at an atomic level, the things that are inside these boxes look different from each other. And hence, you can see that they're made up of or bundled together with different, I guess, a ratio, a different combination of spheres. Okay. As for a element versus a compound, the definition we gave for an element is um, every single sphere is identical. I didn't say every single bundle of particles is identical. I'm saying every single sphere. So here, so I'll do it in blue. And how about I do it as a highlighter? Okay. Every single one of these spheres are identical to each other. Every single sphere here is identical to each other. And even if they are bundled together or what we would call a diatomic, like mono, di, tri, diatomic, every single one of these atoms are exactly the same. That's what we call an element. So then what's a compound? Well, as you can see for this picture, we have a lighter gray and a darker gray. So they are clearly two different atoms, two different types of spheres. However, these two types of spheres are bundled together or paired up in a 1-to-1 ratio every single time. So even if the spheres are different, these packages are identical to each other. So take a look at this one. Every single one of these packages are identical to each other. Every single one of these quadruple sphered packages are identical to each other. So that's what makes a compound. from a visible perspective. So we're going to get more into that when we talk more about atoms and whatnot. But for now, that's our definition. So we had a chance to uh, organize that. So after we sort of labeled this as elements and compounds, and this big block was mixtures, I got into the larger umbrella of elements and compounds, calling them to be pure substances. We call them pure because, again, every single, I guess, package, whether it's atoms or molecules, every single thing was the same. It was purely, pun intended, sort of, purely one type of particle. Okay, whether it's a molecule or atom, it was one type of particle. So going down, oh, keep this in mind because that was one of our little homework assignments. You had to create a classification of matter chart on a single 8.5 by 11 piece of paper. I'll get more into that at the end of the video. So we went, everything is made up of matter. Matter is anything that takes up space and has mass. You might remember me talking about mass and volume when we were doing ecology, of how energy is something you can't hold. Energy doesn't take up space, but we're talking about matter here. There are 3 different ways we can classify matter. And the first one is element. So every single sphere is the same. Compound. Okay, so in this case, glass is going to be a compound, and well, that's a bit of a lie. Glass is actually a mixture of a whole bunch of different things. But for the sake of this example, every single one of these glass particles is made of 1 gray and 2 white. Specifically, what is it? It will be 1 silicon and 2 oxygens. You don't have to worry about that, but you get the point. The third one is going to be a mixture because air is a mix of carbon dioxide. It's got a mix of oxygen. It's got some nitrogen. It's got a whole bunch of stuff in there. Okay, so to start talking about your homework. So the first part is matter. Everything is matter, right? Is made of matter, but that can be broken down into pure substances, and mixtures. And out of these 2 umbrellas comes elements, compounds. We've got something called mixtures that you can actually see all the parts together. We call them heterogeneous. Okay, mixtures. In other words, we can see 2 or more phases, like 2 or more parts. So for example, if I have a beaker of water and I poured sand into it, clearly you see the sand sink to the bottom and there is a layer of sand on the bottom with a layer of water on top. Another example is, if your teacher ever did this for you, if you mix oil and water, the oil is very, very light compared to water. So the water sinks and the oil floats. The last category is homogeneous or homogeneous. And that is, we know that it's a mixture, but you only see 1 phase or 1 body. One example is salt water. If I have water and I add salt in it, salt might go to the bottom, but sooner or later it's going to dissolve and you actually just see 1 phase. You don't see the crystals of salt suspended throughout the water. It's dissolved in. So that's a homogeneous mixture. Your homework is to give me 3 different examples of each. 1, 2, 3, 1, 2, 3, 1, 2, 3. And try to, for homogeneous and heterogeneous, try to have some kind of food and some kind of drink in here. For compounds and elements, if you can find something that you have at home, that'd be great. I'll give you a freebie. For example, if you got, gold jewelry, then there you go. Pure element should be about 24 karat gold. Like, who's that guy that sang the song? Anyways, I'm so terrible at this stuff. Anyway, there's gold. Anyways, fill this in, and if you can hand it in, that would be a quick homework assignment. Letting me know that you are able to classify matter. It's not a big challenge to you. Okay. Following, this is straight from the textbook. But I'm just going to give it to you here. There are, now that we talked about, I guess, matter and the different ways that particles can be classified, we start talking about the behavior. And so one of the things we establish is this thing called particle theory of matter. A theory is an accepted explanation in science without direct observation. So you can't quite prove it per se, but we see it, the behavior happen again and again and again. And so we call it a theory, and it's just sort of accepted. Okay, the particles that make up matter are so small that they cannot be seen even with different technologies. Here are 5 different key points. I'm going to see if I could remember off the top of my head. The first point is let's see, particles are always moving. Okay, that'd be 1. How about just write it like that? Number 2, particles with more energy. In other words, for example, temperature will move faster. 3, particles are attracted to each other. In other words, there is this to each other. There is an invisible force that is trying to pull the particles together. You learn more about it in grade 11 chemistry if you choose to take it. But for now, we just say that particles, there is some kind of invisible force keeping particles together. Number 4, particles have space between them, which makes sense. If they are constantly moving, they have to have space between them. And then lastly, number 5 should actually be number 1. It's that everything, all particles of I guess a single matter, of like some object, is all the same. So it sounds a little bit weird, but here's an example I can give. Like back then, way back then, we thought like all cheese was made of cheese particles, right? Cement was made of cement particles, and you know, whatever. Like, anyways, as that evolved, of course, that definition didn't hold because cheese was made up of smaller and smaller building blocks. But we do know that as we broke it down, for example, like water, all water particles were the same, right? When we broke it down, all oxygen particles are the same. All particles that make up, I don't know, I guess salt, we would say it's all the same. So using these 5, as simple as they might be and as obvious as they might be, they can actually help explain a lot of different, I'm going to call phenomenons in this world. And as a class, we got some practice using these as a way to defend our explanations in the examples below. So take a look. So I gave a rubric of how I might evaluate you on a quiz or a test when you have answers. And you will see that you can't just answer using your past knowledge. From what I've noticed in your past, like biology, a sustainability test, I've seen how a lot of people answer the questions correctly, but not necessarily through the material that they learned this year, but through their like other learnings, or just use their natural intelligence to try to, answer the way out. That's not going to fly in the future, especially for chemistry. So we got some practice. Here's an example. Why do you need to add air to your tires in the winter, but let them out during the summer? Explain this using particle theory. Some people will be like, oh, air gets hot, so it expands. That's why it's going to blow out the tire, so you need to let it out in the summer. And when air gets cold, it contracts. So you have to put in more tires to keep it inflated in winter. How would you answer that question without chemistry knowledge? Well, you might have heard or seen hot air balloons, and hot air balloons go up because hot air expands and it's less dense or whatever. See, that wouldn't be enough. You would get like maybe a mark of 1 or 2 out of the 4 if you did that. You're not referring to the particle theory of matter. So here's how you might refer to the particle theory of matter to answer this question. So you still talk about temperature, right? As temperature increases, you would say particles move faster? Right? Because according to the particle theory of matter. And you could say as particles move faster, there is more collision with the walls of the tire. So you can think about as particles are moving all over the place, clearly there's going to be more collisions. It's going to be bounce off everywhere. It's going to collide with each other. It's going to collide with the walls. And when that happens, there is more pressure on the tire walls, which may blow the tire. Therefore, you must let air out during summer. You can also say the exact same thing for winter, right? As temperature decreases, particles move slower. As particles move slower, there are less collisions, and so it will make the tire feel less inflated. So you got to put more air in to increase the number of collisions inside. Here's another example. When you go down, why is it that water pours easily from a container, but honey pours very slowly? Viscosity, because you people being gifted, you know a lot about how to describe things and you're very good with your words. But in this situation, if you just mention viscosity, saying, oh, that's a scientific word, I'm good, I'm going to get my marks, it's not enough. You need to explain using the particle theory of matter. So here's an example. Well, all particles, so again, you are referring to one of the 5 bullet points that we made. All particles are attracted to each other. But honey particles have a stronger attraction than water. So that's your explanation. It's not viscosity, but like, why is it more viscous? Well, we assume that honey particles are more strongly attracted because honey particles want to stick together. It will have a harder time, I guess, rolling off or out of the container or something like that. Just anything like that that refers to one of the 5. Our class had more than one suggestion. Some people talked about maybe it's the temperature, right, that caused it to move faster, but it doesn't say anything about temperature here, so we can assume that the temperature is the same, so that wouldn't quite be accepted. The third example here is pretty cool. Why do puddles of water eventually disappear after a rainstorm? Again, you can, ooh, that's my baby crying. Give me a second. That was a little embarrassing. Anyways, I think you get the point. See if you can explain these kinds of phenomenon, quote unquote, using the particle theory of matter. Okay, that would be our first lesson. Once you can complete that, we had a classification exercise sheet. So again, here, there were 16 squares. Can you count the number of different numbers of atoms? So in this case, there would be, okay, count the number of the atoms out there, and then count the number of molecules in that same picture, and then tell me if it's an element or a compound. So in this case, so number 1, look at these. I would say there's only one type of element, one type of sphere, so one type of element. And how many different kinds of molecules are there? There's only one type of molecule. And so all in all, that describes an element. For number 3, how many different spheres do you see? I see 2 different types of spheres. How many different packages do you see? Every single one of these molecules or packages looks to be exactly the same. So I'm going to say I only see one type of molecule, and therefore I would say this is a compound. Whereas with this one, I see 2 different types of spheres. However, these 2 are the same. This is clearly not. So I see 2 different types of molecules. This is going to be a mixture. That was an exercise. The answer key is available in class. Fill all that in. And then we moved on to this one. Again, just take a look at the description and tell me if it's an element, compound, homogeneous, or heterogeneous mixture, and a bunch of questions here, a bunch of practice here. The answer key is already provided inside the classroom, so you can take a look. One final point. There are some times where it's hard to distinguish whether it's an element or not because you may not be familiar with the periodic table. As a pointer, iron, nickel, iodine, platinum, gold, copper, hydrogen, and mercury are all going to be found in what we call the periodic table. Ta-da! It's somewhere in here. You can go on a bit of a scavenger hunt to see if you can find it, but that's our first lesson. So that's essentially 2 lessons worth smashed together. I know the video is long, but I hope it helps, and wait for the next one.